Welcome everyone to the next Chilventa Specialist Forums. Let's go ahead and get started with the next presentation. It's titled R-32 versus R-454B, which is the best choice. I am Chris Crosby with Arkema Refrigerants. So the agenda for today, we'll go over a quick goal of the presentation. We'll do a review of the regulations that have been leading to all of the refrigerant changes in the industry. And then we'll go over the two R-410A replacement choices in R-32 and R-454B. And we'll review the properties of those refrigerants, the performance simulations, TWE calculations, and then a few design and adoption considerations, and then wrap things up with a conclusion at the end. So the goal of this presentation is to provide a fact-based comparison of R-32 versus R-454B to help OEMs decide which product best meets their application, considering their thermodynamic properties, the composition of the refrigerants, the capacities and efficiencies, flammability, charge size, compatibility, and performance in a system. So we'll start with the regulatory issues that have been pushing these refrigerant changes over the years. The whole goal of the phase down of HFCs is really to avoid up to a 1/2 degree C global warming by 2100. HFCs have been used globally since the phase out of ozone depleting substances. However, they also have a high global warming potential, so there's the need to phase those out as well. Regulation globally is really just designed to reduce the use and emissions of HFCs. So on the right, you can see if nothing is done, the HFC emissions continue to grow over the years up to the year 2100, and that's what's driving that 1/2 degree C global surface temperature increase. So the global phase down of HFCs really started with the Montreal Protocol many years ago, and that was a multilateral agreement to protect the ozone layer. Over the years, that has been amended several times with the Montreal Amendment, which phased out HCFCs, and then with the Kigali Amendment, which is phasing down HFCs. Then in other parts of the world, there are additional regulations. So in Europe, as many of you are familiar, there are the F-gas regulations. These reduce the use of HFCs, expand the quota system, preventing emissions, and then putting in place better monitoring and also capping the production of these products. In the U.S., this is driven by the Environmental Protection Agency, or the EPA, and the U.S. Has EPA regulations that are phasing down the use of HFCs, and this is done primarily through the AIM Act, which is made up of 3 pillars. The first is the allocation and phase down of the production and consumption of HFCs. The second pillar of that is reclaim, so managing the use of refrigerants, taking those refrigerants back at the end of their life and then reusing them. And finally, the technology transfer, which is transitioning equipment to alternative refrigerants. So diving into the 2 refrigerants that we wanted to talk about today, which are R-32 and R-454B, these are primarily used to replace R-410A. R-410A has been in use since 2010 in the U.S. And before that in some locations, but it is comprised of R-32 and R-125, so 50% of each of those components. So looking at the 2 alternatives, first you have R-32, which is just 100% R-32. Then you have R-454B, which is 68.9% R-32 and 31% R-1234YF. Looking at the flammability, 410A, of course, was an A1 non-flammable refrigerant, and now R-32 and R-454B are both A2Ls. And then we see the GWP reduction. This is, one of the primary goals of this process. And so we're reducing the GWP from 2,088 to 675 with R-32 and 465 with R-454B. Being a pure refrigerant, R-32 has 0 glide, whereas 454B has a slide glide at 1.2 K. Both products are very stable and have good material compatibility. When you look at the cost compared to R-410A, typically R-32 has a lower cost than R-410A, and R-454B may have a slightly higher cost. Availability of both products is very good, and then 410A, of course, is becoming more difficult to obtain as it's phased out of production. Charge sizes, typically with R-32, you can reduce your charge size the most, but you can also do a slight reduction in charge with R-454B as compared to R-410A. Efficiency and capacity, both of those increase with R-32. R-454B is really designed to match the capacity and efficiency of R-410A. And then finally, PFAS. R-32 is not considered a PFAS, whereas R-454B, because it contains the R-1234YF, does fit the definition of a PFAS. Quickly looking at the pressure and temperature comparison between these three products, you can see that the red line is R-454B. It falls slightly below the vapor pressure of R-32 and 410A across the temperature range. R-32 and R-410A are fairly close in vapor pressure throughout the temperature range until you get to some of the more elevated temperatures, and then R-32 typically runs a little bit higher vapor pressure at the elevated temperatures. So because we are dealing with a blend in R-454B, we'll take a look at what happens if you leak refrigerant. Of course, if you're leaking pure R-32, you have no issue with leaks. Whatever leaks out is R-32, and whatever is left in the system is R-32. So you can top off that system and have no issues. R-454B, there will be a slight change in composition as it leaks off, because you do have two different components with different vapor pressures. So the R-32 typically will boil off faster than the 1234YF. And so your composition changes to become more skewed in the 1234YF direction as you leak that refrigerant out of a system. So we did some simulations to compare what the composition would look like as you leak that refrigerant out of the system. And so as you leak that refrigerant out, the material becomes out of spec, which is that plus or minus 1% range, after you lose about 11% of your total mass of refrigerant. So after that point, the refrigerant blend is no longer considered in spec and becomes more skewed towards 1234YF, which will impact the performance of the system, potentially detrimentally, because you're losing that R-32 refrigerant. And we also looked at, if you leak 10% of your refrigerant and then recharge the system back to its intended charge, how many times can you do that recharging process before the refrigerant goes out of spec? And what we found was that you could safely recharge the system twice after a 10% loss before the blend goes out of spec. After that time, you would need to pull the entire charge and recharge with virgin refrigerant. So comparing the performance of R-32 and R-454B across the temperature condensing temperature range and evaporating temperature range, you can see that R-32 typically runs a slightly higher volumetric capacity than R-454B. This is not completely surprising, considering R-454B is almost 70% R-32 with 1234YF added to it, which is a lower capacity refrigerant. So the capacity does drop slightly for R-454B across the temperature range. Very similar story on the mass flow rate of the refrigerant. In order to obtain the same capacity, you typically need to run a higher mass flow rate of R-454B when compared to R-32 across the range of condensing and evaporating temperatures. The next comparison we wanted to look at is the TWE comparison. Funny word, but just looking at the total equivalent warming impact of each refrigerant. And basically what this does is take into account the total emissions of the refrigerant, whether that be direct emissions or indirect emissions. So the sum of those, both of those, would be the TWE. So for direct emissions, you look at the GWP of the refrigerant, the charge size in the system, estimated leak rate of refrigerant over the system expected life, and then the recovery rate at the end of the life. So at the bottom, you see the assumptions that we made for each refrigerant using the GWP and assumed charge size for an example system, 8% leak rate over a expected system life, and then a recovery rate at the end of life. On the indirect emission side, it's energy consumption times your electrical emission conversion factor. For these calculations, we use the assumptions for both products of several U.S. cities and the USA weighted average electrical emission conversion factor. So the locations that we chose across the U.S., we tried to choose a location in the northern section of the United States, somewhere in the central United States, and then a couple of southern locations within the country. And you can see the calculations for TWE for both of these products, really a very small difference across the board. R-32 is a little bit more favorable in hot climates, whereas it showed that 1234YF might be slightly favored in some of the more moderate climates. However, the differences here are really very small for both products. So what are the selection criteria that OEMs use when they're converting from 410A to other refrigerants? And in this case, particularly R-32 and R-454B. So typically, the OEMs that we deal with are looking at the compatibility, material compatibility of each refrigerant, along with the materials of construction, looking at the cost of the refrigerant, what are the current regulations and GWP requirements, what type of flammability can you handle in your system, and then how do these refrigerants affect the efficiency and capacity of your system, and what are your needs for that efficiency and capacity. And then finally, how compatible are these products with your current system. So looking at the two products, R-32 and R-454B, we can see from a GWP perspective, R-454B has a slightly lower GWP than R-32. They are both A2L refrigerants, so they require the same, basically the same amount of work in that regard for adopting them into a system design. On the efficiency and capacity properties, R-32 has an advantage on efficiency and capacity. However, you may not need the enhanced efficiency and capacity in your system, and that does require typically redesign from a R-410A design. So if the goal is to have the same design for your system as you had with R-410A, then R-454B may provide an advantage there and some cost savings on the R&D side. And that's where we go into the current design compatibility. R-454B is fairly compatible with current R-410A system designs with some slight modifications because it is an A2L, so that does have to be taken into account. However, R-32 is typically not compatible directly with an R-410A system. You do need to do some redesign to the system to enhance due to the enhanced capacity and efficiency of the refrigerant. Finally, both refrigerants are compatible with most materials of construction in an R-410A system, so no major changes there. And then neither product can be retrofitted into an R-410A system because of the flammability, the A2L flammability of the refrigerant. So wrapping up the presentation and the comparison of the products, both of these products, R-454B and R-32, are very good replacements for R-410A in air conditioning. R-32 is really the best if you are designing a new system and going through that full design process to take advantage of the enhanced efficiency and capacity of the refrigerant. However, if you are simply looking for the fastest, simplest transition from R-410A to a low GWP refrigerant. R-454B is a simpler transition in that equipment, and most of the equipment designs do not have to be modified greatly to use that refrigerant, aside from the flammability concerns. So there's very low R&D in converting an R-410A system to R-454B. However, with both of these products, there may be new, even lower GWP refrigerants that will be needed in the future based on changes to the regulations that are coming in the future, as well as PFAS regulations. So in the end, R-32 is used in both of these products and will continue to be used in blends in the future, and is a non-PFAS product. So it does have that advantage. However, as I said, both of these products are very good and very compatible for R-410A system redesigns. So feel free to reach out to myself or my colleague who is also in our technical group with Arkema, Gus Verlotti, who contributed to this presentation. Feel free to reach out to either one of us or just to Arkema in general, or come visit us at our booth in Hall 9 at booth 408 anytime today, and we'd be happy to talk to you about either of these products. So thank you very much for your time, and feel free to approach me after the presentation with any questions that you might have. Thanks a lot.